Okay, good, excuse me. Good morning. We're here heading for section 6.4, where we're going to multiply and divide these radicals. And let's just jump into it. So I'll start with example 1. And I'm not going to let you sit there and watch that, so I'll be right back. Okay, that's better. And let's try it out here. So we're multiplying these two guys as indicated by the parentheses. So what I want to do is separate these. I want to multiply the 3 times the 2. I don't know that's like the coefficient, really. So it's kind of like multiplying 3x times 2x. And we do them separately. I'm doing the coefficients of 3 times 2, and that's what I'm going to do here with the radicals, the 3 times the 2. 2 and the 3 are both outside the radical sign, so 3 times 2 will give me 6, and now I can multiply like we would the x's, multiply them together. That's the only commonality. But then I'm going to multiply the square root of 5 times the square root of 7, which will give me the square root of 35. So all we're doing is multiplying the 5 times the 7, which we're allowed to do, and that gives me 35. And so I've got the square root of 35 left. Now, in future problems, you may have to take that 35 and simplify it. But with 35, as you can see, I'm going to have 7 times 5. And these are both prime numbers anyway. I only have one number of each, but I need 2 to take 1 out. So this would be my final answer for example 1. Okay? All right, let's go on to the next one. Okay, here in example 2, we are going to demonstrate the distributive property. This is going to look like, give me a little bit more room here. So I'm going to distribute this here, square root of 3, to the 2 terms inside the parentheses. Now this is a radical 3 times 2 times radical 6. So that means this is going to end up equaling 2 times the square root of 18. 3 times 6 is 18 under the radical. And then it's going to be minus square root of 3 times 5 times the square root of 12. Well, that looks like it's going to be negative 5 square root of 36. 3 times 12 is 36. Now what I want to do is simplify both of these. All right, this is 18, so that would be 2 times the square root of 9 times 2. If I can do it that way. You can do the expansion if you want. The square root of 9 is 3, so that's going to come outside, and that's going to be 2 times 3. Scooch it up here. 2 times 3, radical 2. That's what's left inside here. So then I'm going to multiply the outside, 2 times 3, which is 6, and that gives me 6 radical 2. Okay, that's the first part here. Did I get a pointer there? Okay, and now I'm going to do the same thing to the right side. So this is 5 times the square root of 36 is 6. So that gives me 5 times 6 is 30. And that's it. That's all I can do with that. Okay. I can't do any combining. I don't have like terms, in other words. And I'm done. All right, next we have example 3. And now here we have 2 binomials that we're multiplying, so we get to do what? We get to FOIL. We get to FOIL this. All right, so first is the square root of 3 times 4 times the square root of 3, which would really be 4 times the square root of 9. And I'll leave it like that. Okay, I know I'm going to have the square root of 9 to simplify. Then I'm going to do the outside, which is the square root of 3 times the square root of 5. So that's going to be negative square root of 15. So that's outside. Inside are these two, which is going to give me what? Positive 4 square root of 15. Okay, like that. And last will be the square root of 5 times negative square root of 5, which will be negative square root of 25. Okay, let's simplify some of these items here. And I'm going to have 4 times the square root of 9, which is 4 times 3. Square root of 9 is 3. And that'll give me 4 times 3, which is 12. Here I've got like terms, so I got negative 1 plus 4 is 3 square root of 15. So that's going to be positive 3 square root of 15. Just combining my like terms in this case. And that'll be minus square root of 25, which is 5. All right. So far, so good. Let's combine our like terms here by saying 12 minus 5 is 7. 7 plus 3 times the square root of 15. I can't simplify that square root of 15 any more than what it is. So that means I'm completely done here. I make sure you do not add 7 plus 3 to make it 10. Then you're failing the order of operations. Okay, you got to multiply before you add. So make sure you don't. That's a common mistake people make. All right, but that's our answer for number 3, example 3. All right, how about example 4? You remember we have a binomial squared. We could do it the shortcut way. I'll tell you what, I'll do it both ways just for the fun of it. All right, I really would be interested in you learning this shortcut deal for the future. So you have it in the future to know. So when I have a binomial squared, I can do the shortcut way by squaring the first term, which would give me x, multiplying the 3 numbers that you see that are visible. That means 2 times 3 times the square root of x, which would be plus 6 square root of x. Just multiplying these 3 together. That's all you see in the problem. And now to finish it up, I'll have the square root of, not the square root, but the 3 that I'm going to square. And that'll give me 9. Okay. Now you say, can I combine anything here? No, I'm done. Square the first term, multiply the 3 terms that you see, and then square the last term. And then you're done. If I do it the FOIL way, what have I got here? Let me do some housekeeping here. You may recognize that problem. All right, so let's try this. And what we say was square root of x plus 3 times the square root of x plus 3. And now I'm going to FOIL that. All right, square root of x times square root of x is x. Square root of x times 3 is positive 3 root x. Inside is 3 times square root of x, which is another one. 3 square root of x. And then last is 3 times 3, which is 9. And there you can see it developing. These two are my like terms. So I'm going to have x plus 6 root x plus 9. What's next? All right, so here's another binomial squared. So I can, again, do the, the shortcut way, which would be by squaring the first term. So this one here would be 3 root x squared. Squaring that. And then I want to multiply these three terms. Wow. So let's see. I'm going to first do the coefficients. I'll call them coefficients. The 3 times the -2 times 2. And that's going to give me -12. And I've got the square root of x times the square root of y, which is going to be the square root of xy. Okay? And then what's next? I'm going to square this last term here, and that's going to be -2 square root of y squared. Looking good. Move this up a little bit. And I'm going to square this now. So this is going to end up being 9x minus 12 root xy. And then this is going to be minus, and I'm going to square that. And it looks like it's going to be 4y. No, I must say I made a mistake here. This negative, I got to take it here. I got to include that negative because that's really -2. Well, let me get my thing back here. Okay, so I have to enclose that technically, to say this is really what we're going to square, that -2. If we square it, that becomes positive. So that would be plus 4y. Okay, that's what happens there. And then I'm looking for anything I can combine, which we don't have anything. So this is our solution now for that one. Okay, so remember that part there. Easy to let that negative remain on the outside. Okay, next problem. No, not the next problem. I want to expand this and do the FOIL method with us for that same problem. All right, so I'm going to have first for the FOIL, 3 times 3 is 9. Root x times root x is, how shall I say it? The square root of x squared. Okay, I want to be sure on this. That's why I'm actually writing this up as x squared, the square root of x squared. All right, so that's the first. The outside is 3 root x times -2 root y. And what's that going to get us? -6 root xy. Inside is going to be the same thing. -2 times 3 is -6 root xy. And last is going to be -2 root y times -2 root y, which will give us that positive 4 root y squared. Now I'll go through and simplify whatever I can. Scooch this up. So here I'm just going to have 9x. Square root of x squared is x. This will be -12 root xy. And that takes care of the 2 in the middle, plus 4. And the square root of y squared is y. That looks like the same answer we had earlier. And then I rectified that sign being positive. Okay, real well, real good. Now let's move on to the next one. Okay, wow, check this one out. Here's another binomial squared. So I'll try I'll do the shortcut way. All right, what does that mean? I'm going to square the first term. All right, so if I go the square root of x plus 2 and I square it, that's fine for now. And my middle term are going to be these three terms multiplied together. So we got 2 times -1 is -2 times the root of x plus 2. Well, that's going to give me -2 root x plus 2. Okay, and then I'm going to take the -1 and square it. All right, so let's go through one more time and simplify it. So I've got the square root of x plus 2 squared is going to be x plus 2 minus 2 root x plus 2, and then this will be plus 1. Can I add anything together? The 2 and the 1 I can add together. So I could write this up as x plus 3 minus 2 root x plus 2. And by George, I think we've got it. Okay. If I expand it and do it, let me take a moment and rewrite it, then I'll be right back. Okay, here is the other method, the longer way, or FOIL, and let's FOIL it. So I've got my first, our square root of x plus 2 times the square root of x plus 2, which is just x plus 2. And then how about the outside, square root of x plus 2 times -1, which is negative square root of x plus 2. And then inside is -1 times the square root of x plus 2, which is another negative square root of x plus 2. Okay. And lastly is -1 times -1, which is +1. All right, and then let's just clean it up a little bit. I've got x plus 2, and then I've got minus 2 square root of x plus 2 plus the 1. And how about we just add the 2 and the 1 now, just like we did earlier. 2 and the 1 is 3, so I got the same answer. X plus 3 minus 2 square root of x plus 2. There. And we get the same answer that way. Okay, great. Next. All right, here is example 7. And notice we have the product of the sum and the difference of the same two terms. But I'm just going to FOIL this as we've done in the past. All right, these are a little bit more difficult to pick out when you're in the heat of battle, when you're, on an exam type of problem. So you can look at that and say, well, they're two binomials, so we can just FOIL it. So let's do that. Square root of 6 times the square root of 6 is the square root of 36. Outside is the square root of 6 times negative square root of 2. That'll give us negative square root of 12. And then the inside is going to be the square root of 2 times the square root of 6, which is positive square root of 12. And lastly, I have square root of 2 times the negative square root of 2, which is negative, it's going to be negative square root of 4. Very nice. So what do we have? Square root of 36 is 6. Negative square root of 12 plus the square root of 12 is 0, so that cancels. And then I've got negative square root of 4, which would be negative 2. And 6 minus 2 equals 4. And that's our answer for example 7. All right, in example 8 now, we're going to change gears a little bit by using division of radical expressions. All right, and if you remember, we had, I got an example in our textbook here that when we rationalized the denominator earlier in 6.2, we had something like the square root of 3 over the square root of 2. And when we rationalize that denominator, we'd multiply top and bottom here by square root of 2 in this case, and square root of 2. Okay, and what happens to the denominator is it ends up getting out of the radical sign and just becomes a number. So square root of 2 times the square root of 2 is the square root of 4, which is 2. So it's out of the radical. And then on top, if I finish that, it's the square root of 6. And I can't simplify it any further. Okay, that's for a radical that's in the denominator when we have to rationalize it to release it out of the radical sign. Now in this section here, we're going to have a binomial with radicals. So then the rule is going to change, and what we want to do here is, we want to multiply the top and bottom by the conjugate, what's called the conjugate. All right, so if I have, let's say for example, a plus b, the conjugate of a plus b is a minus b. And that results in the product of the sum and the difference of the same two terms, like we did previously in our previous problem. Let's see, I can zoom up to that. I had the sum and the difference of the same two terms. And when we have that is called what I just said it was, but then we end up with an answer that ended up being 4, just a single number outside of the radicals. And that's the objective here that we're doing with this multiplying by the conjugate. All right, so with real numbers, these are just letters, so let me get rid of that just to say what the conjugate of that binomial is. And let's go on here to say I'm going to multiply, let me change my color here. I'm going to multiply top and bottom here by the conjugate. And the conjugate is going to be square root of 5 plus the square root of 3. And then again, what I do on the bottom, I have to do on the top. And let's see what happens. So when I multiply these two guys, again, I'm foiling that. So I got square root of 5 times the square root of 5 is the square root of 25. Outside is positive square root of 15. Inside here is negative square root of 15. And last is going to be negative square root of 9. Okay, so I am now going to, I can't remember, I don't want to forget, I got to do the numerator too in this problem. So let's see, I'm going to have square root of 25 is 5. Positive square root of 15 minus square root of 15 is 0. And then I just have minus the square root of 9, which is 3. And 5 minus 3 equals 2. So this is my denominator. That 2 is going to be my denominator. And then if I move it up here a little bit, I'm going to multiply this 6 times the square root of 5 plus the square root of 3. And let's see, that'll get me 6 root 5 plus 6 root 3. And that's going to be over, I really didn't have to do that, over 2. That was my denominator. I'll bring it over here. And when I simplify this, I could have done that earlier, but, this suffices. I'm going to have 3 root 5 plus 3 root 3. And that will be my final answer. Yes, so that is example 8. All right, I am multiplying by the conjugate, rationalizing the denominator, top and bottom, and do your multiplying. Okay, and here is example 9. Looks like our last example. And let's rationalize this denominator because we have to get that radical out of the denominator. All right, so that means I'm going to multiply top and bottom here by the square root of 5 minus 2. Square root of 5 minus 2, top and bottom again. All right, when I multiply this, let's see, these and these. So if I FOIL it, I'm going to have square root of 5 times the square root of 5 is square root of 25. Outside is going to be negative 2 root 5. Inside will be positive 2 root 5. And 2 times negative 2 is negative 4. All right, putting it all together here, let's see what I end up with. I'm going to have square root of 25, which is 5. Minus 2 root 5 plus 2 root 5 is 0. And then I got minus 4. And 5 minus 4 equals 1. That's in our denominator. Okay, that's fair enough. And then let's figure out what our numerator will be. I'll scooch it over here. And this is what I'm going to multiply together. And what will I have here? I'm going to have square root of 5 times square root of 5 is square root of 25. Square root of 5 times negative 2 is negative 2 root 5. Inside is negative 2 root 5, so that's minus 2 root 5. And lastly, negative 2 times negative 2 is positive 4. All right, and let's continue on. So I got the square root of 25 is 5, minus 4 root 5. My signs are the same, so I'm going to add those up and give me negative 4, and this is going to be plus 4. 5 and 4 is 9. I can combine those two, and that'll give me 9 minus 4 root 5. And I guess that's it. I can't combine anything else, so this is complete. Done. Okay, and that was example 9. So that's it for this lecture. Continue your good work, and we'll be through this semester before you know it. Got another couple sections of Chapter 6 and Chapter 7 to go, and we'll be done. Okay, have a good day, and talk to you later.